Okay, now we're going to talk about exponential functions a little bit more in depth. We're going to talk about the graphs here. In order to talk about the graphs, it's really important that you understand how to graph these yourself. You're not going to be able to graph these. You're not going to be able to do the assignments if you cannot figure out how to make your graph match these here in front of you. If you really cannot figure out how to make your graph on your calculator graph these graphs in front of you, you need to set up a Zoom appointment with me. Capiche? Okay. So just a reminder, you can download Desmos for free onto your phone. There are also several TI-83 sort things that you can put on your calculator, on your computer, your Chromebook, and your phone. Also on your computer, right now they're letting everybody use the TI-83 stuff for free. Okay. So back to number one. Number one is just kind of normal looking. It looks a lot like the one I did an example of where your domain is all reals. See, they never stop from left to right. You're looking from left to right. When I look from left to right between these two bars, it does not stop. But it does stop if I look at the lower part. You can see that it's never going to cross the x-axis. So you know that the domain is all reals and the range is y greater than 0. Now we look at number 2 and we've got the same situation, but look, dun dun dun, they're almost the exact same numbers, right? And look how different they look. This one over here has this one over here. I gotta point to it, don't I? This one over here has a y-intercept of 0, 3, and this one over here has a y-intercept of 0, 2. Okay, then, so you can, when you flip-flop those two numbers, the one with the x with it and the one without, you change the whole shape. Again, if you have questions about what I'm saying, you need to set up a Zoom appointment. So number 3 and number 4 is where we start to see some crazy changes. If you look at number 3, we are subtracting 2 from the exponent part of the function. If we look at number 4, we are adding 5 to the exponent part of the function. If you look at number 3, we have moved down. We have moved down exactly 2 units. If you look at number 4, we have moved to the left. We have moved to the left exactly 5 units. That's what that's all about. And I wanted you to see that in an example, and hopefully I won't prattle on too much more. Okay, so in number 3, your domain is still all reals. It's always all reals, but your range changes. On number 3, your y is greater than -2 because it moved down 2. On number 4, the graph looks different. The domain and the range are the same as the parent function. Exponential decay is slightly less relevant to our everyday lives, or at least the math that most of us would do in our everyday lives. It has a lot to do with predicting the path of a hurricane, the Richter scale. The Richter scale is what determines the magnitude of an earthquake, or the strength of an earthquake, or how scary an earthquake is. Exponential decay also determines how old dinosaur bones are and how old the rock is. So archaeologists deal with this a lot. But most of us aren't going to go into any of those fields. So I'm going to go through this a little bit more quickly. The information that was boxed on exponential growth is also true for exponential decay. But I'm going to do a couple of examples the way that I did on the top half of this page, and then we're just going to, the only thing I'm concerned with this piece is making sure you know how to use your calculator. So you need to make sure that you know how to make the graphs on your calculator match what's in front of you. That's all your job is right now. And if you cannot figure that out, you need to set up a Zoom appointment with me. I cannot speak clearly enough about that. So in a few seconds, you're going to see a whole bunch of graphs appear, and I will explain the important information about each. Okay, this is what exponential decay looks like. Exponential decay, at first, everything deteriorates really, really quickly. Like if you put food trash somewhere, it deteriorates really, really quickly, and then it turns into dirt, and then it kind of doesn't deteriorate as quickly, right? Okay, so because that is actually exponential decay. So there's something really important that I forgot on this entire page. So I'm going to fix that in a second, but I want to talk about these exponential decay functions real quick. So if you look at the first one, you see that your domain is all reals and your y is greater than 0. But on the next one, you subtracted 1, and when you subtract 1, boom, 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 that changes everything so that it moves down 1. So it all moved down. On the number 3, it actually, you subtracted 5 from the x, which is backwards from what you expect, but it still makes it move to the right. So that's old information about functions that you learned a long time ago that you probably don't remember. When you subtract from the x, it moves it to the right. When you subtract from the whole thing, it moves it down. When you add to the x, it moves it up. When you add to the whole thing, it moves it up. Okay, I'm going to write all that down, and then I'll be back. Okay, so again, in any function, if you subtract from the x, you end up moving to the right, just like the one right below my words. If you add to the x, you move to the left. If you subtract from the y, you move down. If you add to the y, you move up. The big mistake I made here was that I forgot the domain and the range on number 3, so I'll fix that real quick before I fix my big, huge, giant mistake. Okie dokie. So you're going to have to be able to find the domain and the range, and in order to find the domain and the range, you really need to understand these graphs. But the big, huge mistake I forgot is I forgot to label my x and y axes, and I forgot all of my indices, and that is a big, huge, honkin' deal. Okay, so now if you look at my graphs, I did not label every single thing, right? I just made it clear how much it's skipping by. I labeled x and y. I only put little ones or negative ones. One time I put a 3 and one time I put a 2. It just needs to be clear what it's jumping by, and that jump needs to be very clear. So if you're not graphing on graph paper, you need to make sure that those jumps are very, very even. The drawing needs to be very clear, and you need to be clear about what you're jumping by. Otherwise, it makes it very easy to create graphs that are deceptive and incorrect. And you don't want to be lying to your public if you're a businessman or a journalist, and you don't want to be lying to your college algebra teacher if you are in high school or college. That's all I have for today. I do have an activity prepared for my Zoom lessons this week. It's not just a check-in this week. I'm looking forward to seeing all of you, and I will talk to you soon. Y'all take care. Bye-bye.